Okay, we're going to go over page 37A, which is on transformations. Now, there's four main types of transformations we're going to go over: translation, reflection, vertical stretch, and vertical shrink. And I'm going to give you an example of each one. Now, first, I want to go over the concept of a parent linear function. A parent linear function is f of x equals x, or simply y equals x. It is the most basic linear function. It's the most basic because the slope is 1 and y-intercept is 0. Okay? So, I'm going to graph the parent linear function, start with a y-intercept of 0, go up 1 over 1, up 1 over 1, up 1 over 1, and I'm going to draw the parent linear function. Now, you're going to draw the parent linear function on the next 8 graphs. And a quick way of doing it is you say point here, point at the origin, point here, and then you just connect them. So go ahead and stop the video and draw the parent function for all of these graphs, because after that, you're going to graph a different function and compare them. So now I'm going to graph g of x equals x plus 3. How does this differ from the parent function? Well, it has the same slope, but a different y-intercept. So I graph the y-intercept. I go up 1 over 1, up 1 over 1, up 1 over 1. And when I graph this, I notice the lines are parallel. They have the same slope, but a different y-intercept. What made the y-intercept change? The plus 3. This is a translation. When the slope doesn't change, but it shifts up or down the y-axis, that is a translation. So this was a translation up 3. If we look at the next one, this is going to be a translation down 4. How do I know it's going to go down 4? Because it's subtracting 4. The slope is the same. The only thing that's different is the y-intercept. So I go to -4. I go up 1 over 1, up 1 over 1. That is a translation. So a translation is always parallel to the parent function. It just goes up and down the y-axis. Okay, so now the next one we're going to do has a slope of 2 over 1. So it has a different slope, but the same y-intercept. We're going to start at the origin. We go up 2 over 1, up 2 over 1, up 2 over 1. So for this, a stretch is when the absolute value of the slope is greater than 1. In this case, 2 is greater than 1. So this is a vertical stretch. Now, anytime you're this direction away from the parent function, it is a stretch. You're pulling away from the parent function and you're pulling away from the x-axis. That is a stretch. Compare that to this one, which is a shrink. Now, this is a shrink because the slope is 1 over 2. When the absolute value of your slope is in between 0 and 1, it's a vertical shrink. Now, anytime it goes in this direction, closer to the x-axis, it is a shrink. And what made it shrink was the slope was in between 0 and 1. Okay, so now let's turn the page. Okay, so now on the next page, we're going to get into a reflection. Okay, so for this one, notice that the slope now is -1. So our slope is negative. Whenever your slope is negative, this is a reflection. Okay, so when I graph this, instead of going up one, right one, I go up one, left one, up one, left one. And this is a reflection. Now for my next one, not only is this going to be a reflection, why is it a reflection? It's a reflection because M is negative. But it's also going to be a stretch. And why is it going to be a stretch? Because the absolute value of M is greater than 1. Notice we're looking for magnitude, not sign. Because the negative sign just makes it a reflection. The 3 makes it stretch. So I start here and I go up 3 over 1, up 3 over 1, down 3 over 1. And this is a stretch and a reflection. Now the next two have multiple transformations. Here, the 1/3 is going to make it shrink. Because the absolute value of M is in between 0 and 1, it's going to shrink. And because I'm adding 1, it's going to translate. So this is going to be a combination of a translation. So I start here and then I go up 1 over 3, up 1 over 3. And this is what it looks like. Then for my final one, I have -2x minus 1. The minus 1 makes it translate down. The absolute value of the slope is greater than 1, so it's a stretch. And the fact that M is negative makes it a reflection. So this is a translation, a reflection, and a stretch. I start at -1, I go down 2 over 1, down 2 over 1, and it looks like that. Okay? So, now if you look at the next page, this tells you all the different rules for translation, reflection, stretch, and shrink. And if we look at page 25, I'm just going to quickly go over these and discuss what type of transformations they are and why. So, here I'm adding 9, so if you're adding 9, that's a translation. Here, I'm subtracting 10. This is a translation down 10. Here, I'm multiplying by 5, so the absolute value of M is greater than 1, so it's a vertical stretch. Now here, my slope, the absolute value, is in between 0 and 1. So this is a vertical shrink. Here, my absolute value is greater than 1, so it's a stretch. And here, two things. The absolute value of my slope is between 0 and 1, So that makes it shrink. And the fact that this is negative makes it reflect. Okay, so that is a short review on transformation.